Today, we're going to unpack something that is honestly a truly mind-bending paradox. We are exploring why the unimaginably vast distances of space mean that our seemingly crowded cosmos is actually terrifyingly silent. I want to take you on a journey that's going to fundamentally change how you look up at the night sky. We're going to travel from our own local cosmic backyard all the way out to the very physical limits of the universe just to understand the profound nature of our isolation. To kick things off and really wrap our heads around this isolation, we have to ask ourselves one fundamental question. Just how empty is the universe? Because, to understand the silence, we first really need to understand the physical space that this silence actually lives in. Let's dive right in by contrasting our everyday human intuition with the harsh reality of the cosmos. Think about it. We are entirely used to a world that feels incredibly full and connected, right? You can hop on a plane and literally be on the exact opposite side of the planet in a matter of hours. But the cosmos? It operates by a totally different set of rules. Out there, distances are so immense that objects are, practically speaking, permanently unreachable. The sheer void between stars and galaxies is a reality that our terrestrial brains simply cannot process. Let's just anchor ourselves for a second before things get way too abstract. Think of it like a cosmic address. Stepping outward, we leave our own solar system and enter the much wider Milky Way. But the Milky Way is really just one of roughly 50 galaxies in our local group. And that local group? It's just a tiny speck inside the massive Laniakea supercluster. It all sounds pretty neatly organized when we list it out like that, but the actual physical space between these steps is absolutely staggering. Just to go anywhere locally requires an unimaginable amount of time. Take the Voyager 1 spacecraft, for example, which launched back in 1977. It's currently hurtling through space roughly 23 billion kilometers from Earth. Yet, even traveling at its incredibly fast current speed, it still needs roughly 30,000 years just to exit the Oort cloud. That's a massive shell of icy debris that marks the true outer edge of our solar system. We haven't even directly observed this outer region yet, but that is exactly how far our immediate backyard extends. And the escalation gets even wilder when we try to go just a little bit further. If we wanted to, say, cross the street to our absolute nearest neighboring star, Proxima Centauri, which is 4.2 light years away, it would take us 70,000 years with our current technology. I mean, that is longer than recorded human history just to reach our next-door neighbor. But here's the kicker. Even if we magically invented microscopic probes that could make the trip in a fraction of the time, the reality still remains pretty bleak. The nearest planet there, Proxima Centauri b, orbits a red dwarf, and that's a volatile type of star that constantly blasts the planet with intense, completely life-destroying radiation. So for all intents and purposes, we are completely alone locally. Now, let's scale it up. Imagine you were traveling at the absolute speed limit of the universe, the literal speed of light. It would still take you 100,000 years just to cross our own Milky Way galaxy as it orbits around the supermassive black hole at its center. And those faster-than-light warp drives you always see in sci-fi movies? Well, they require exotic physics that we have never even proven to exist. Because of this incredible emptiness, we get some really counterintuitive situations. For instance, we know for a fact that our Milky Way is on a collision course with the Andromeda Galaxy, and naturally, you'd expect a catastrophic, fiery crash. But in reality, space is so overwhelmingly empty that when these massive galaxies finally merge, individual stars will just gracefully pass right by each other. They're going to weave together without ever actually touching. This staggering scale literally turns our telescopes into time machines, right? Think about it. It took a physical probe, New Horizons, 9 years to reach Pluto. But look at light. When we look up and see the Andromeda Galaxy as a faint smudge with our naked eye, we are actually seeing light that left 2.5 million years ago. That's before modern humans even existed. And today, the James Webb Space Telescope is capturing light from galaxies that is 13 billion years old. It's literally showing us the universe exactly as it looked less than a billion years after the Big Bang. Okay, let's zoom all the way out. On a macro level, the universe looks like a massive cosmic web. This absolutely mind-blowing structure of giant filaments and incredibly empty voids actually originated from quantum fluctuations. Those were tiny random blips of energy in the infant universe that just got stretched to a massive cosmic scale as space expanded.
So, our specific neighborhood within this giant web is called Laniakea. It was defined back in 2014 by mapping the motion of thousands of galaxies toward a mysterious region called the Great Attractor. Laniakea spans a whopping 520 million light-years across and contains a staggering 100,000 galaxies.
But honestly, the emptiness inside this web is just as terrifying as the massive structures themselves. Take the Boötes Void, for example. Discovered in 1981, this anomaly spans approximately 330 million light-years. Now, based on the average cosmic density, there should be thousands of galaxies in there. But instead, we find only a few dozen. It is just this massive, unfathomable pocket of absolute nothingness. And then, on the exact opposite end of the spectrum, we find structures so overwhelmingly large that they actually break our current understanding of physics. The Hercules Corona Borealis Great Wall is this massive cosmic filament estimated at up to 10 billion light-years in length. It's so incredibly huge that some cosmologists seriously question whether our current models can even fully account for how it exists at all. Which brings us to a massive existential pivot point. When you consider the billions of galaxies, the hundreds of billions of stars per galaxy, and the likely trillions of planets, why haven't we heard a single whisper from anyone else? We've just explored the isolating physical scale of the universe, but what about the biological one? This deafening silence is what we call the Fermi paradox. Statistically speaking, someone should be out there. But our utter lack of contact usually boils down to three pretty haunting possibilities. Number one, we might just be looking in the wrong place or listening for the wrong kind of technology. Two, we might just be way too early to the party. Or three, and this is the most concerning of all, something called the Great Filter is stopping civilizations dead in their tracks. Let's dig into that last point, because it is pretty unsettling. The Great Filter is a theoretical evolutionary hurdle. It suggests that life simply doesn't survive long enough to become an interstellar species because some insurmountable obstacle always inevitably wipes them out. In this scenario, the rise of a galactic civilization is just statistically improbable. And that forces us to ask ourselves a pretty heavy question about humanity's future. Have we already miraculously passed this filter, making us a super rare exception? Or is the ultimate civilization-ending test still waiting for us somewhere in the future? It's the kind of question that makes the silence of space feel incredibly heavy. But you know, astrophysics offers us another entirely different reason for this silence, one completely separate from biology. It is called the cosmic event horizon. This is a hard, physical, observational limit sitting roughly 16 billion light-years away from us. Beyond this invisible barrier, no light, no radio signal, and no spacecraft can ever reach us. So why does this horizon even exist? It's all because of dark energy, that mysterious force driving the accelerating expansion of the universe. Because space itself is stretching faster and faster, those distant galaxies we can see right now are physically moving away from us at such high speeds that they are eventually going to cross that event horizon and just disappear from our view forever. So, what should we actually take away from all this? Well, the fact that we hear absolutely nothing isn't just a frustrating lack of data. This cosmic silence might actually reveal more about our lonely, isolated place in the universe than any single scientific discovery ever could. It's perhaps the most profound piece of information we have about the relentlessly isolating laws of physics. I'm going to leave you with this final, somewhat haunting thought. Because of this accelerating expansion, the universe is actively erasing its own history. As scientists have pointed out, future civilizations are going to look up at a completely dark sky, with absolute zero evidence that other galaxies ever even existed. Our current beautiful view of the cosmic web, it's strictly temporary. Thank you for joining me on this explainer today. So what do you think? Are we incredibly lucky to be able to see the universe exactly as it is right now? Or are we just incredibly alone?